Okay, thank you for your kind introduction, Professor Saiful Amin, and good morning, everyone, and thank you for joining this seminar. I would like to explain about chapter 3.2, which describes how to retrofit flat plate column joint. First of all, this is the image of flat plate structure assumed in our project. In our project, SATREPS-TSUIB project, we assume the flat plate structure have beams on its perimeter. So this is the floor plan and beam layout. So the building has beam on its perimeter, but interior column do not connect it to beam. So the main target of this chapter is to retrofit this kind of column, do not connect it to beams. This is the general flow of this guideline, or it is already explained by Professor Sanada. And in the case of flat plate structure, this general flow can be drawn as this flow chart simply. First, determination of retrofit scheme based on the limitation value of F, and the upper limit of F index in the case of flat plate structure. The keyword of this guideline, one of the keyword in this guideline is loss of structural integrity. In the case of flat plate structure, the loss of structural integrity will be caused by punching shear failure. So in the case of flat plate structure, we verify the deformation at the punching shear failure before. So, and as a result, we use the upper limit of F value 2.6 for punching shear failure. So if the expected F value, expected deformation is smaller than this value, we can retrofit flat plate structure according to the PWD manuals. If no, we have to judge needs improving the structural integrity and check the punching shear failure is expected or not. If it is not expected, we can go to this route and retrofit to the building according to the PWD manual. But if the punching shear failure is expected, we need to apply this section. So in this section, we provide two retrofit technique. One is wing wall, the other is drop panel to prevent punching shear failure. The main purpose of this chapter is to prevent punching shear failure. This is the image of retrofit. So before talking about retrofit, let me briefly review the seismic evaluation of flat plate structure. This is again a floor plan of flat plate structure. It has beam on its perimeter. And for the loading to X direction, we can consider only these columns shown in red circle because it is connected to beam in X direction. In the case of this column, it is also connected to beam, but in only Y direction. So the seismic evaluation for X direction, we neglect this column. And also, we neglect these three interior columns because they are not connected to beams. And these columns have possibility failing punching shear failure. And this figure shows the relationship between strength index C and ductility index F. So this black line indicates the performance curve of the structure. But this structure has the possibility of punching shear failure. So the upper limit of F, it is 2.6, is applied. So this blue one is performance point of this structure. And if the demand is shown in red line, this demand curve, the blue point is lower than this line. So the seismic capacity of this building do not satisfy the demand. So we have to retrofit it. For example, if we can remove the upper limit of F 2.6, the performance point move to right side, and here it is beyond the red curve, so it satisfies seismic demand. However, in the case of the green line, if the seismic demand is shown in green line, the red color is also not enough. So we have to increase strength as well as deformation. I will explain about the effect of wing wall and drop panel in detail later, but the conclusion is the drop panel is this kind of retrofit. Just remove the upper limit of F index. And retrofit by wing wall is increase the strength as well as deformation. So I move on the explanation in detail about wing wall retrofit and drop panel retrofit. This is a general of chapter 3.2.2, application of wing wall. The purpose of wing wall retrofit is to prevent punching shear failure. And if the columns are retrofitted by wing wall, the columns without beam can be considered in the lateral load carrying capacity. It means wing wall increase the C index of the structure. And the contribution of columns with beams retrofitted by wing wall. With beams, it is almost same as usual moment resisting frame. So it can be evaluated according to the PWD manuals. Again, this is a flowchart of seismic retrofit. I will explain about the flowchart in the case of wing wall installation. If we apply wing wall, we need to check F index after retrofit. If F is larger than 2.6, the upper limit of F, we have to check the possibility of punching shear failure by comparing M slab and M punch. M slab is the capacity of slab flexural yielding, and M punch is the capacity of punching shear failure. So if this equation satisfied, M punch is smaller than M slab, punching shear is expected. So we have to prevent this failure by installing wing wall and calculate C index and calculate F index. And after that, we can go this way and retrofit according to the PWD manuals, because we already determined C and F indices for the flat plate structure. This figure shows how to calculate M slab. M slab, by installing wing wall, the critical section of slab move from the edge of column to edge of wing wall. So this moment is the capacity of slab. And assuming double curvature, as shown in this figure, we can calculate the nodal moment at the flexural yielding of slab. It is M slab. And this figure shows the calculation of M punch, the capacity of punching shear strength. This figure shows the floor plan, and it is interior column. The red rectangular represents the critical section of punching shear failure. And as already introduced, the calculation of M punch in the previous seminar by Professor Buyan, M punch is sum of three components: flexural capacity of critical section and shear components and torsional components. The sum of these three, we can obtain M punch, the capacity of punching shear. It is before retrofit. So after retrofit, we can change the critical section of the punching shear failure. Left-hand side, the seismic force is this direction. So wing walls is installed in plane direction to the seismic force. In this case, we assume this red dashed line as critical section. In the case of transverse direction, wing wall is installed transverse direction, we assume this red dashed line as critical section. It is same as before retrofit. This figure shows the comparison between calculation and the experimental result. Red line shows the calculated result of punching shear strength, and the black curve represents the experimental result. So it agrees very well. So we decided to apply this critical section for calculation of M punch. In the case of transverse direction, the red line is a little bit smaller than experimental result, so a little bit conservative estimation. But if we apply this enlarged critical section for this case, it overestimates experimental result. So at this moment, in this guideline, we decided to apply this critical section for conservative estimation. So now we can compute M slab and M punch, and we can compare with each other and decide and estimate the flexural, estimate the failure mode of flat plate column joint. And after making sure that we can prevent punching shear, we calculate the contribution of column, interior column. So to calculate the contribution, first we compute QU. It is lateral load carrying capacity of a column with a wing wall. And after that, we calculate C index, just divided by the weight of building. QU divided by weight of building, we can obtain index C. And index F shall be calculated from the PWD manuals. This is the image of calculation of QU. These figures show how we derive this equation. Flat plate structure is very flexible structure, so the behavior is very similar to cantilever column. But if we assume this plastic hinge, assuming the yielding of the bottom of column with wing wall and yielding of slab at the edge of wing wall, we can draw this moment distribution. And for simplification, we change this moment distribution like this figure, right-hand side figure. So just gather M slab at the top of wing wall. This is the reason why we use this equation to calculate QU. And so now we can calculate QU. So after calculation C index, F index, we can go to the general flow. So from this slide, I'd like to explain about drop panel. Drop panel, the effect of drop panel is a little bit different from wing wall because it is same. To prevent punching shear, drop panel is also effective. But the contribution of columns without beam cannot be considered. So drop panel can only remove the upper limit of ductility index. It is the effect of drop panel. So this is a flowchart for drop panel. First, we decide application of drop panel and check the upper limit of F index. And if the F index is larger than 2.6, we have to check the failure mode. And if punching shear is expected, we install drop panel to prevent punching shear. And just remove the upper limit of F index. The contribution of column retrofitted by drop panel cannot be considered. So just remove upper limit of F index and go to the general flow. Retrofit according to the PWD manual. This is an image of calculation of M slab. It is quite similar to the case of wing wall. So the critical section is moved to the edge of drop panel, and we can calculate the nodal moment at the flexural yielding of slab. And this is the image of punching shear strength, calculation of punching shear strength. The critical section is enlarged by installing drop panel, like shown in this figure. And the calculation is shown dashed blue line, and the red line is experimental result. It also agrees very well. So we can assume this critical section for the calculation of error punch. And after the calculation, if we can prevent the punching shear failure, we can remove the upper limit F equal 2.6. So this is the summary of this chapter. Both wing wall and drop panel are effective to prevent punching shear failure. And wing wall contributes on the increasing of C index, only wing wall. Drop panel is not, it do not contribute because just remove F limit. And both wing wall and drop panel contribute on the increasing of F index. Thank you for your kind attention.